Good morning, students. So today we are going to start with a new chapter, that is structure of atom. Okay. So in the structure of atom, this is very important. It is general chemistry topic. So for your syllabus, it has 5 marks question, 3 plus 2 or 4 plus 1. Okay. In this, only one chapter consists of 4 plus 1. 4 marks one question is there, that is based on quantum number, and 2 marks one is there, 1 marks one is there. Total 7 marks question it is. Means this chapter carries 7. Okay, so right here, this is what structure of atom. So you know that atom, what is matter, what is atom, what is molecule, you already know about that. Okay, so atoms are the smallest indivisible particles of a matter. Okay, these atoms are the smallest indivisible, means they cannot be separate, they cannot be divided of what? Of matter. For example, H2O is there, H is atom, O is atom. Okay, C6H12O6 is there, glucose. C is atom, H is atom, O is atom. That is what? The smallest indivisible particle of the matter is called as what? Atom. And remember, you know that one oxygen of course consists of 6.023 into 10 power 23 atoms. Correct? So in this, only one atom we have to consider. Okay, this atom is indivisible and it is the smallest composition of the matter. Okay, so we know that matter atom is there. So in that atom, nowadays we know, of course, electrons are there, protons are there, neutrons are there. So that's why they are stable. Understand? So in nowadays, what we are studying means in that we already came to know. So in an atom, it is not only a small particle. So within the atom, again further subatomic particles are there. Okay, what are the subatomic particles? One is electron, proton, and neutron. Okay, so protons and neutrons are present in the nucleus, and electrons are revolving around the nucleus. That is what today's what is the definition of atom or a subatomic particles we know. So from that electrons and protons and neutrons, we can say what is atomic mass, what is atomic number. Understood? So before the discovery of protons, neutrons, and electrons, even though oxygen is present, understood? We have not yet discovered what is atom, what is matter. Even though water is there, air is there, oxygen is there, nitrogen is there. Okay? So many scientists worked on that, how they exist, what is the reason for their existence. Understood? And they keep on doing so many experiments, and some of the scientists are succeeded to identify the atoms. And what are the why atom is stable? What is the reason for stability of atom? Understood? So and another one is, of course, this atom is the smallest indivisible particle, but even though it consists of a further small particles called as subatomic particles. Subatomic particles. What are those subatomic particles? Protons, neutrons, and electrons. You know, always they stay together. If protons, neutrons, and electrons are equal, or as it is, sorry, how many electrons are, for example, you know, carbon is there, here it is 6, 12. Correct? So here proton is 6, later I will say electron is also 6, neutron is also 6. If any one is less, either electron or proton or neutron, this carbon atom is become unstable. For example, I'll take only proton and electron because they have charge. So this proton charge is here plus 6, electron charge is minus 6, this is neutral, 0. So it is balanced. So that's why your net charge is 0. If you take C6, 11. Means proton here is 6. Electron here is 6. Understand? Neutron is 5. Of course, neutron charge is 5, sorry 0, but then also they become unstable. You take just C 5 or C 6 12 minus. Means one extra electron is there, C minus carbon ion. Then here proton is 6, this one electron is 7 because minus charge is there. Neutron is 6. So here the net charge is minus 7 because it is plus 6, it is minus 7, 0, so minus 1. So minus 1 is the net charge. Then this become unstable. Okay? So what I am trying to tell is, if the protons, neutrons and electrons are balanced, then only the compound or atom or a molecule can exist in a stable form. Any one of this is imbalanced, okay, either less or more, so then the compound or a molecule or atom become what? Unstable. Understood? Okay. So listen, these are the subatomic particles, protons, neutrons and electrons, and of course they are indivisible. We cannot separate them. Okay. So now we know electrons are the, neutrons are the, protons are the. Okay. So before identifying these subatomic particles, we have a blind idea how can they exist. By God they exist. Okay. So later so many scientists discovered that subatomic particles. In that the first one is discovery of electron. Discovery of electron. I'll go one by one. So in this chapter, what we are going to study means discovery of subatomic particle and models of atom. Like so many scientists, what is that? Understood the experience or suggested, proposed that atomic models. Some are like watermelon, some are like what is that? Sphere, like this concentric circle. They assume atom may be like this. They assume atom may be like in the form of a watermelon. Okay, so many scientists are trying to give their opinion on the structure of atom. Later they fail, and today what we are applying for structure of atom is the quantum atomic model. That is the last model what we are presently using. Okay, later I'll explain that. So initially we just go through this. So discovery of electron. So students, before going to the idea of discovery of electron, so what is the main the scientist behind this is Faraday. You know Faraday's electromagnetic induction law is there, and Faraday's electrolysis law is there. So this scientist, what he did, he conduct electrolysis process. Means in a chemical reaction, he arranged two electrodes. One is cathode, another one is anode, and he supply current to that. When he supply current, then chemical reaction takes place. Anode reaction and cathode reaction separately takes place. In that, he observed exchange of electron. For example, here it is cathode, here it is anode also. So cathode is positive in charge, anode is negative in charge. Here, cathode. So this one is anode, left side. This one is cathode. Always anode is situated at left side, cathode is at right side. And this is positive in charge, this is negative in charge. So students, if it is positive in charge, which ion is going to attract means of course negative ions. Positive attracts negative. The charge of this electrode is positive, but it attracts negative species. Okay? Okay. Now, this one is plus, this one is minus, sorry. Why? Because cathode charge is negative, it attracts cation, that's why it is called as cathode. Cation means positive in charge. So this one, anode charge is positive, okay, it attracts negative ions, that's why it is called as anode. Anion negative, anode positive. Cation positive, cathode negative, just opposite. Electrodes are opposite in charge with respect to the ions. Cation means positive, cathode means negative. Anion means negative, anode means positive. So students, here always oxidation takes place. Here, reduction takes place. Remember, oxidation means loss of electron. Right here, loss of electron. Reduction means gain of electron. Okay, just remember, anode positive charge, so oxidation takes place. Oxidation means loss of electron. Cathode, which is negative charge, reduction takes place means gain of electron. Minus charge means nothing but negative species attached here means what? Of course, negatively charged species means they are electrons. Gain of electrons means of course reduction is going to happen here. Understood? So means if any year it is zinc metal you consider, if copper is considered. So here electrolytic solutions are there. I will take like this. Two solutions are there. This one is copper sulfate. This one is zinc sulfate. Just I am telling the electrolysis process, and they are interconnected with the salt bridge for the movement of ions. For the movement of electrons, they are interconnected by a salt bridge. Any one of the salt will be taken there, either KCl or NaCl like that. Understood? Now, so students, here zinc rod is there. This electrode is made up of a zinc rod. What happens here? Oxidation. Oxidation means loss of electron. Means this zinc rod, assume it is 1 kg. Zinc rod having 1 kg. So this zinc loses electron. Means zinc loses electron, becomes zinc plus 2 electron. Means here loss of electron takes place means this rod changes to zinc plus 2. Then what happens? The size of the rod decreases. Correct? Here zinc is there. It is converted into ion here. Zn Zn plus 2 plus SO4 minus. Understood? So that is what oxidation takes place here. Next here here reduction takes place. Means Cu plus 2 is in the ion. This electrolyte is there, CuSO4 means Cu plus 2 is there. This Cu plus 2 accept these 2 electrons and become Cu. Cu is what? Electron. This Cu is deposited here. Then what happens? The size of the copper or the mass of the copper increases, or the mass of this cathode increases. So from this experiment, he concluded that so when we supply electric current, a chemical reaction takes place. Due to that chemical reaction, anode concentration decreases, cathode concentration increases. Understood? So then he started working on this. What is the reason for this reaction and the apply of the electric field? Okay, what happens? So then he got an idea and he conducted the experiment to the discovery of electron. Okay, so that is called as cathode ray discharge tube. Okay, so discovery of electron is done by Faraday by cathode ray discharge tube. Cathode ray discharge tube. So what is that arrangement means? I will write here. Okay, so this one is vacuum pump. Okay, here 2 electrodes are there. I'll take here. Two electrodes are there. So here, this one, of course, these are externally connected to a battery. These are externally connected to a battery. And this one is anode, charge is positive. And this one is cathode, charge is negative. Understood? And here inside this we are taking a gas. Okay? So inside this gas is there. In that gaseous molecule, of course, gases also consists of atoms. Those atoms consist of protons, neutrons, and electrons. So this tube, the setup, is called as what? Cathode ray discharge tube. Okay, the name itself says cathode ray means this one. Cathode means this one. The rays are emitted from cathode towards anode. Okay, discharge. That is what remove. From what? From what is removed here? Cathode ray. What are those cathode rays? The ray which is discharged from here towards anode. Okay, so students remember what happens in this experiment means. Listen here. So initially this is the setup. So this Faraday taken a vacuum pump. In that a gas is inserted of different pressures. It may be a same gas, a different gas. We don't bother about that. Okay. So next, he adjusted the pressure, and it is must be a low pressure. He adjusted low pressure. You know, nitrogen, oxygen, and helium gases we applied here as you. So helium may have less pressure. Oxygen may have more pressure. So the pressure of those gases is balanced by this vacuum pump. You know the pressure is balanced by vacuum pump and you know that. Okay. So the pressure of the gases is maintained as a low pressure with this vacuum pump. So the condition here is what? Low pressure and high voltage. Low pressure and high voltage. So how this experiment takes place? So listen, when the low pressure is maintained and when the sufficient amount of voltage is supplied, means electric current is supplied, then we can observe movement of a rays, means cathode rays towards anode like this. Movement of rays, okay, I'll just draw this. Just assume inside that gaseous molecules are there. I have to show the movement. So the cathode rays start moving towards this anode. Understand? This is going to happen. This is what cathode ray discharge. You know, there may be a chance of movement of the rays from anode to cathode. Understood? Anode to cathode movement may also takes place. But here, what is happening here? Only the cathode ray discharge tube. In that, only cathode rays start moving when the electric voltage is applied. High voltage is applied. Only these rays move towards this anode. Not anode rays cannot move towards this cathode. Understood? They are moving towards anode. And these are not affected by any magnetic field. Okay, so these rays cannot be affected by magnetic field because we are considering what? Only electrons. Okay, later another experiment is there, same experiment, but it is considered with respect to charge as well as mass. Then the experiment varies. Later I will explain. So this is what experiment, and we don't know. How can we conclude? So we cannot see the rays passing. Okay, by our naked eye, we cannot see the movement of the electron, and at the same time, is that possible? We cannot see the what is the pressure, and we cannot see this also. What is the supply of electric field? So how can we come to conclude that? So listen, behind this electrode, initially, of course, they did hole here and as well as here, and they assumed. So when they made hole here at this side, they won't get any glow light. Okay, this is right? They made a hole here and they placed a fluorescent screen here. non-fluorescent phosphorescent. This is what? Phosphorescent plate or lining, anything you can say. Phosphorescent plate or phosphorescent lining or phosphorescent material, whatever it may be, this set. Okay, so then what happens? So listen here, when the canal rays, later I will say what are canal rays. So these rays, when they pass through this hole and then touches this fluorescent screen, sorry, phosphorescent screen, then what happens? Here glow up takes place. Means we can observe a spot of bright light. Understood? When these rays start moving from cathode to anode, they pass through the hole made in that anode and they fall on the phosphorescent screen. When they falls on the phosphorescent screen, we can observe a bright light. Then what is the conclusion we need? Of course, when we spot that bright light, we can easily say, of course, the rays are moving from cathode to anode. Similarly, if you place the phosphorescent line here, okay, how much electricity you supply, whatever you apply, extra pressure, current, anything, here you won't absorb any light because the rays are discharging from here towards anode, not from here to here. So this is the experiment done by Faraday. From this, he concluded this. So these are the canal rays. The rays which is discharged from cathode are called as canal rays. Understand? So I write here, these rays are what? Canal rays. Okay? So here it is negative in charge. Negative in charge means of course electrons are present here. Negative in charge means electrons. Okay? That is their assumption at that time. So then he came to know. So he didn't say them electron. He just simply said a negatively charged species start moving from cathode to anode. At that time we don't know the name of the negatively charged species electron. Understood? We just concluded the negatively charged species start moving from cathode ray to anode ray. That only he mentioned. He didn't mention any electron. But nowadays we know they are electrons. Understood? So this is the experimental setup for discovery of electron. Okay. So what are the results of this electron? So initially first one. This one is very important. Result of electron. Sorry. Result of experiment. First one what? Cathode rays start moving from cathode towards anode. Okay, right here. Cathode rays are in a right canal rays. Cathode rays starts moving from cathode towards anode. That is the first one. Second one is what? So when these rays cannot be visible, but they made visible by placing phosphorescent light or phosphorescent screen. Okay, these rays are invisible, but they made visible by placing phosphorescent screen, which causes bright light spot. Okay, that is the second result. Of course, as I told you, they are invisible, but they are confirmed by the phosphorescent light. So another one is in the absence of electric magnetic field, electric and magnetic field also, they travel in straight line. As I told you, they are not affected by any magnetic field and any electric field. Even though in the presence of electric field as well as magnetic field, they travel in a straight line. Okay? And the another one is there. So in presence of electric field, the behavior in the presence of electric field, the behavior of cathode ray is same as that of negatively charged particles. So you know, in the electric current means negatively charged particles are there. So when we supply the electric field, so the movement of that electric field, negatively charged species which is present in current, that and the what is the behavior of the cathode rays, because those are also negatively charged. Both are same that we are going to observe. That's why it never affects. So electric field never affect this movement of the cathode rays. Understood? And the last one is, so the characteristics of this cathode rays cannot depend upon material of the electrolytes. So electrodes, not electrolytes. Where should I write? Okay, and just write here last point. The characteristic of cathode rays cannot or do not depends on material of electrode. Okay, so here the condition I write here. The conditions here is low pressure, high voltage. Okay, so students remember what they said. The characteristic of cathode rays do not depend on material of electrode. Electrode means this electrode may be made up of iron, platinum, cobalt, or any metal. The material is different. Then also the characteristic of canal ray, nothing affected. Why? So we don't bother about this. Even though whatever may be the cathode, its charge is negative only. Okay, it may be iron, it may be platinum, cobalt, nickel, anything, palladium. Okay, so if it is cathode, its charge is negative only. Of course, the experiment setup is done as it is. So it doesn't affect it by material of the electrode. Okay, and another one thing here they mentioned, in the absence of the electric and the magnetic field, they travel in a straight line. Means if you observe magnetic field here, north and south. Magnetic field is okay. If you insert or if you apply magnetic field in between that, understand? Then also they move in a straight line. That movement of the canal rays are in a straight line. They are not affected by any electric field as well as any magnetic field. So from this, they concluded the atom consists of a negatively charged particle. Listen, this one is made up of what? Metal. Obviously, they are made up of metal. Metals is nothing but they are also consist of atoms, protons, neutrons, and electrons. Gaseous, those are also consist of atoms. Okay, those consist of protons, neutrons, and electrons. Even though they are moving in a straight line. So we concluded, of course, in the atom, negatively charged species are there, and those negatively charged species are nothing but electrons. This is the experiment setup for the discovery of electron done by Faraday. Okay, so the next one is discovery of mass. Nothing. Initially, the charge by mass ratio. Later, in the mass, they came to know protons and the neutrons are there. So first, I explain charge by mass. Okay, discovery of charge by mass ratio. So experimental results are very important in all these. Okay, so discovery of charge to mass ratio. So by J. Thomson. Why? The scientist. Okay, he is the British physicist. So we would find out, sir, who did the experiment based on discovery of charge to mass ratio. He's not particularly studying about charge, he's not particularly studying about mass. So you consider charge to mass ratio means E by M ratio. Charge means E, okay, M means mass. Okay, so he did the same experiment used by cathode ray tube only, but it is some changes. How? So listen here. This is the experimental setup. So here an electrode is there. Here another electrode is there. So this one is. These are externally connected to a battery. Same. Okay. So this one is cathode. This one is anode. This one is negative in charge. This one is positive in charge. So students, what I explained before, the cathode ray discharge tube. So this part is same as it is. Okay, means here the tube is there, as I told you. Okay, here anode is there, here cathode is there, here I made a hole, and here the fluorescent screen is placed. This is the fluorescent screen. Okay, and hole is made here. Okay, similarly, hole is made here. Here, hole is there. Understand? Here the rays are moving like this. Okay, so this is the experiment I'll say it. So which experiment did it? Initially consider, of course, the cathode ray discharge tube. These are the canal rays start moving from cathode towards anode in a bulb manner. Here there is no magnetic field. There is no, listen here, there is no magnetic field. There is no electric field. So of course they are moving in a straight line. But when they passes through this hole, okay, of course the rays are start moving like this in a straight manner. And when they pass on here, they form a spotlight here, a bright spotlight. Okay, so here at this place, Initially, he placed magnetic field, so electric field. Means he applied electric field. One is plus, another one is minus. Of course, plus and minus means nothing but battery. Electric field is applied. So then what happens? These rays, here he didn't apply any field. So inside the cathode ray tube, they are not affected by any magnetic field and any electric field, as I told before. So when they pass it through this anode, okay, then he is going to apply the electric field. Then what happens? They show some deflection. Understood? This will show some deflection. Means electric field is there. So instead of moving straight, this is point A you take, this is point B you take, point C you take. So in the absence of electric field and the magnetic field, they are moving in a straight line and falls at the point B, and they create a spot bright light at point B. So when we apply electric field, they deviate. They deviate means if it is in a straight line, deviation like this are this. The deviation from their path towards means here it is, then it deviates towards A. If electric field is applied, so this canal rays or cathode rays cannot move in a straight chain after passing through this anode. Okay, so by the apply of the electric field, the path is deviated from A towards B. So means the light is spotted at A. So if you remove electric field, okay, so I said if you remove electric field and apply magnetic field, here it is not, here it is soft. Then also these rays are affected. Then what happens? The path of the original cathode ray is straight, but due to the influence of this magnetic field, they deviate towards C. Means we have to observe the spotlight at B, bright light at B, but we are observing where? At C. Means even in the presence of electric field as well as in the presence of magnetic field, they deviate from their original path. So then what happens? Listen, at electric field they deviate in this direction, magnetic field they deviate in this direction. Simultaneously you apply both magnetic and electric field. Here it is minus, here it is plus. Simultaneously apply both magnetic and electric field. Then what happens? By balancing both the fields. Okay, so by increasing the electric field and by increasing the magnetic field, by balancing both, of course we can make that canal ray to spot or move in a straight line only. Understand? Because as I told you, so if electric field is there more, then this is start deviating towards this. At that time we have to increase magnetic field, then it becomes downward. If magnetic field is more, then it is start deviating like this. Then we have to increase electric field strength. Then it is moving in like this manner. Okay. So when we balance both electric and the magnetic field, they start moving in a straight chain in such a way there is no field strength is affected like that. Means in the absence of magnetic and electric field, they are moving in a straight chain. Straight line. Understand? So similarly, by balancing both magnetic and electric field, we can make these rays to move in a straight line. Okay, so this can be explained. And remember, what are the conclusions he came to? Of course, the key canal rays are there. Initially, they are not affected by any cathode rays and anode rays. But later, when we take the gases of different atoms, of different masses, then they are going to deviate. Okay, if charge on the electrode is more, deviation is more. Okay, if mass of electron is less, deviation is more. Means lighter particle shows more deviation, denser particle shows less deviation, like that. Okay. Of course, by balancing both electric and magnetic field, we can what is that? We can set the experiment in a such a way. Of course, the canal rays can behave in the absence of in a such a way how they behave in the absence of electric and magnetic field. What? Even the presence of magnetic and electric, they are balanced in a such a way the cathode rays can behave how they behave in the absence of electric and magnetic field. ಅಂದ್ರೆ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿರಲ್ಲ ಅಲ್ವಾ ಆ ಟೈಮಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಚೈನಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ. ಈವನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಡಿವಿಯೇಷನ್ ಆಗೋದನ್ನ ಇವೆರಡನ್ನು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿ ಸೇಮ್ ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗೋ ತರನೇ ಮಾಡ್ತೀವಿ. ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಯಾವಾಗ ಮೂವ್ ಆಗುತ್ತೆ ಅದು absence of magnetic and electric field. Even though if we balance, it is moving in such a way means that is balanced. Means these particles are affected by, of course, magnetic and electric field. So finally, we find out by balancing this E by magnetic field and electric field, we consider the E by M ratio is 1.75 into 10 to the power of minus 10 to the power of 1.75820 into 10 to the power of 11 coulombs per kg or gram. Charge coulombs, mass kg. This is the value he got from E by M ratio. Understood? So this is our about what is the discovery of charge to mass ratio by J.J. Thomson. So what are the conclusions I told? The magnitude of the negative charge on the particle. Okay. So greater the magnitude, greater is the deviation. Okay. So I write the conclusions here once again. Okay. Means results here. Greater the negative charge, greater the magnitude of negative charge on particle, greater is the deviation. Means if negative charge is more, then deviation is more. This is the deviation. Okay. Next. Lighter the mass of particle, deviation is more. Means mass of the particle is light, means smaller mass, greater deviation. Greater mass means weight is less, means of course less deviation. Weight is less, more deviation. Weight is more, means less deviation. Means mass is more, less deviation, because it is so weighty. Mass is less, they are lighter molecules, then the deviation is more. Okay. The deviation of rays can increase in presence of electric and magnetic field. Okay. The part is adjusted in such a way it seems to be in absence of any field by balancing electric current, right here, electric current, magnetic field. Okay, so the last point I write here because it is very, very important. So finally, E by M ratio is 1.758820 into 10 to the power of 11 column per kg. So these are the experimental results. Yes. So the greater the negative charge, greater is the deviation. Smaller the mass, greater is the deviation. Charge by mass we are telling. So greater the charge, deviation is charge. Deviation is more. So smaller the mass, deviation is more. Listen here only you can see. E is directly proportional, M is inversely proportional. Correct? If it is in the denominator, it is inversely proportional. Means one increases, another one decreases. This is directly proportional. Means if it is increases, the remaining another one also increases. Directly proportional, inversely proportional. And remember this, then you can write these 2 points. Another one, of course, they are deviated in the presence of magnetic field as well as electric field. And this is balanced in a such a way they are moving in the path in a straight chain, like in the absence of both magnetic and electric. Finally, the charge by charge by mass issue we got is how much? 1.758820 10 to the power of 11 coulomb per kg. Okay, so this is all about discovery of charge to mass ratio by J.J. Thomson. Remember this. Okay, so in the tomorrow's class we will discuss with how the mass of electron will be calculated by using these 2 values. Understood? And how the protons and neutrons are discovered. Okay, thank you.